Okay, in this chapter, or video, we're looking at chapter 10, section 6. So yes, we skipped section 5, so you didn't miss anything. There's no glitch with these videos. We are just going to really hone in on what's really important right now for 7th grade. So we're in chapter 10, section 6, and we're doing quadrilaterals. And this is a part 1 of the video. So if you're looking for part 2, you already did this one. Okay, so go to part 2, okay, if you're looking for that. But we are in part 1. So you have St. James heading at the top, then you write chapter 10, section 6, and then you write quadrilaterals underneath that, nice and neat, and then you write part 1. Okay, a quadrilateral, yes, you're writing all this down. A quadrilateral is a closed figure with 4 sides and 4 angles. That's the basis of a 4-sided figure. That means it's a quadrilateral. Okay? Now, we'll get more specific, but quadrilaterals are named based on their sides and their angles. So, I have here a diagram. You're going to want to do a print screen on this. Freeze the video, do a print screen, print it out, just because it's going to be a little easier than trying to draw all these different shapes. Okay, so you have a trapezoid here, and there's 2 different kinds of trapezoids technically. You have a trapezoid, standard trapezoid is the one that's the first one here, and the sides are all different sizes. Maybe it's like a 1, 2, 3, 4 trapezoid, but you have still 2 sides that are parallel. You can see this side is parallel, and this side is parallel. So you have 2 sides that are parallel, and then 2 sides that are not parallel. The isosceles triangle, or trapezoids, mean that these sides are the same length. We still have 2 sides that are parallel, but then these red sides are actually the same length. They're congruent with each other, whatever the measurement may be. Maybe it's 4 inches or 4 miles, but that little notch here says that they are the same length. Okay, back up top here, rectangle. As you know, 2 sides are the same length, and then the opposite 2 sides are the same length. So that's why I gave that indicator here. These 2 sides are the same length, and then these 2 sides are the same length. And then obviously all 4 corners are right angles. All 4 corners are 90 degrees. A square, very similar to a rectangle, only all 4 sides are the same, and then all 4 angles are the same. A rhombus, it's kind of tilted. It's a parallelogram with 4 congruent sides. So a rhombus could look like this, kind of smushed as well. I'll even make it more smushed. Okay, a rhombus could look like this. So the sides are all the same, but the angles will not necessarily be the same. So you're not going to see any right angles on a rhombus. They're going to be different. So they're kind of like squished. They're parallel with 4 congruent sides. So rhombus will look more squished sometimes. Okay, a kite, it's like a rhombus, only 2 sides are the same, and the other 2 sides are the same. So it's kind of like a rhombus, but not quite. Okay, and then of course your parallelogram is your rectangle. I always say it's kind of pushed to the side so that it's like leaning. So you still have 2 sides that are the same, and then the other 2 sides that are the same, and then it's leaning, in this case leaning to the right. It's kind of just slanted. That's a rectangle slanted is a parallelogram. So the angles on the inside are not 90 degrees. Okay, so let's classify these quadrilaterals as best we can, and you want to use the description that identifies them the best. Okay, so for example, number 1 here, this is a quadrilateral. It is 4 sides and it has 4 angles, but that's not the best description we can give it. What's another name for this shape? If you scroll or look back up at your notes to the top with the diagram, what's the best name you could give this shape? It's a rectangle. That's the best name we could give this shape, a rectangle. Yes, it's quadrilateral, but more specifically, it's a rectangle. Okay, number 2. Number 2, I see here it has 4 different sides. There are no parallel lines, so it's not a trapezoid. You might think trapezoid here, but it's not, because a trapezoid at least has 1 set of parallel lines. This does not have any parallel lines, so this is just a quadrilateral. It is just a 4-sided figure. Quadrilateral is just simply a four-sided figure with four angles, and that's as specific as we can get. Okay. Number 3 here, we're looking at, it is a quadrilateral. It does have four sides. It does have four angles, but we can get more specific, and it's a parallelogram. So you're writing all this down. Okay, parallelogram. And it's just kind of slanted on the side there. Okay, here we have a number 5, or 4, excuse me. We have a quadrilateral. It is four sides. It does have four sides. It does have four angles, but we can get more specific. And this is your rhombus. Okay, again, it could also look more like this, kind of really smushed. Okay, as an example, but all the sides are the same length. That's what that's saying. Okay, all right, number 5. Okay, here we have what you see traditionally, and it is called what? Go back to your notes if you have to, all the way at the top. See, there's two different kinds. To be specific, there are two different kinds, and it's called an isosceles trapezoid. Isosceles trapezoid. Okay, and I put them right next to each other, and here's the other one where it does have two parallel sides, but the other two sides are not the same length, so this is just a standard trapezoid. This is just a standard trapezoid. Okay? There's an isosceles triangle that you really typically think of as a trapezoid, and then because we call it isosceles only because the two sides are the same length. If you call them both trapezoids, you're not necessarily wrong, but we were looking for the best description, so there you go. Okay, now we're going to find the missing angle of each quadrilateral, and just like triangles, all the angles equal up to 180 degrees. For quadrilaterals, all angles add up to 360 degrees. 360 degrees. That's really important to know because, again, we're going to set up our equation because we're looking, obviously, for angle H. So we're looking for the measurement of angle H. Okay, so we would do 105 degrees plus 75 degrees plus 100 degrees plus whatever H is equals, it has to equal 360 degrees in this case. So, yep, there's going to be some addition, adding. So 105 plus 100, that's 205, plus 75 gives you 280, plus H equals 360. Okay, again, the procedure is still the same. I want to get H by itself, so I have to figure out what does H have to be for 280 plus H plus whatever needs to give me 360. So what I'll do is I'll just subtract the 2, nice and neat here, and then H equals what? Well, I got to borrow. Okay, so we get 16. So we get H to equal 80 degrees. So the measurement of angle H is 80 degrees. There we go. So just like the triangle method, instead of it being 180 degrees, everything needs to equal 360 degrees. So the same procedure. Here we're looking for the measurement of angle R. Yes, you're writing all this down. Yes, you're drawing the shape. Okay, so you're still, no matter what the shape looks like, if it's quadrilateral, if it has four sides, we just have to, it all has to equal 360 degrees. So it could be a square or a rhombus or a trapezoid or parallelogram, it doesn't matter. All the angles have to equal 360 degrees. So we have 105 plus 108 plus 72 plus R, whatever the measurement for angle R is, gives us 360 degrees. So we just add everything. 108 plus 72 is 180, plus 105 is 285 degrees, plus R equals 360 degrees. Okay, so if I lost you, I just did 108 plus 72, only because I know 8 and 2 are 10, it just made math easier, and then 180 plus 105, and that gave us 285. Okay, I'm just doing that in my head just so I can be fast. And then I subtract 285 on both sides, subtract 285 on both sides, and I solve for r equals, again, we need to borrow. Okay, and that makes it 10, so you get 5, and you get 7. I'm not sure why it's all of a sudden. Let's be consistent here. Okay, so we have the measurement of angle R is 75 degrees. And you circle your answer. No, you don't need a calculator because your brain is a calculator because you are very smart. Okay, let's try another one. Again, everything just has to add up to 360 degrees. So we have we have 150 plus 50 degrees plus 70 degrees plus, in this case, L, because we're looking for the measurement of angle L. Look at that, angle L. Okay, and it has to equal 360 degrees. So 150 plus 50 is 200, so we're looking for 270 degrees plus L equals 360 degrees. We'll subtract 270, subtract 270 degrees, and then L equals what? Okay, again, you're right, I need to borrow. Okay, so get a 0. 16 minus 7 is 9. So L is 90 degrees. And you don't want to just assume that. Yes, it looks like 90 degrees, but unless that little red box was there, which it wasn't to begin with, you can't assume that. Don't just assume it. You have to do the math and make sure it's actually right. So the measurement for angle L is 90 degrees. Okay, problems for next class. You have 2 figures to figure out. Okay, again, there you go. You have to figure out the measurement for angle A. Okay, and then this one is the measurement for angle B. Okay, so you're looking for A and B. Okay, so have these done before you come to class. Make sure you have them done before you come to class, and I will see you next class.